Hi. Hello and welcome back to Calculus 1. Finally. Right? 2.4 infinite limits. So far, we said that limits are a fancy way to find the y value of the function. It's different than calculating value directly, which is what you learn in pre-calculus. In pre-calculus, you learn that y equals f of x, you plug in the value in f of x, and you compute on the other end, and that's it. Now for limits, we said that you compute everywhere around the point you're interested in, and you infer what the answer would be. But now, sometimes that answer is going to shoot to infinity. So, today, we are observing this form. Limit x goes to some number a of f of x, that it's going to give us positive or negative infinity. So this is what we are observing and trying to understand and learn today. So, a good example of this would be function, say, y equals 1 over x minus 3. We know that this minus 3 on x shifts the function 3 units to the right. Good. So we'll draw our vertical asymptote. So now I am going to draw my orange circle here and point to this limit. X approaches 3 minus of 1 over x minus 3 is equal to negative infinity. So that is what's happening in this circle. So as the function is approaching the asymptote, it is going to negative infinity on the y value. Remember, limits are giving you the y value of the function. In this case, y value is going to negative infinity as you are approaching closer and closer towards 3, which is where the asymptote is because of what the function looks like. On the other side, if you look at the blue circle, you will have limit x approaches 3 plus of 1 over x minus 3 is going to be positive infinity because the y value is shooting up. So we are looking for infinite limits, meaning infinite results, infinite answers, infinite y value. So you are shooting to, as you are approaching from the right, you are shooting to positive infinity here because it's approaching the asymptote. And as you are going from the left side, you're going down to negative infinity. And lesson is over, believe it or not. That's it. Now, we can use this to define something extremely important, obviously. But this is it. This is the concept of an infinite limit. So now, what is this concept good for? Well, it's good for vertical definition of the vertical asymptote. So vertical asymptote, that's a VA. Vertical asymptote is a vertical line
where either limit x approaches a minus of f of x is equal to plus minus infinity, or limit x approaches a plus of f of x is going to give you infinity, or both, whatever. We say VA is at x equals a. Otherwise, VA does not exist, and you are looking into open circle or something else. So you are trained in your pre-calculus to set the denominator equal to 0 and look for vertical asymptotes, right? Unfortunately wrong, right? Because if you do that, you might run into some issues. But let's take a look at some examples, and then we'll recognize those issues as they come up. So here is an example for vertical asymptotes. We have f of x is equal to x minus 6 divided by x squared minus 36. What's happening in terms of vertical asymptotes? What would you say?
It would just be a line, wouldn't it?
It would be the line. At 6. So what did you learn in pre-calc? Good evening. So in pre-calculus you learned that you are supposed to take the denominator and set it equal to 0, right? So if you take x squared minus 36 and equal it to 0, you will get that x squared is equal to 36. X equals plus minus 6. And that will be the end of the story, right? However, now we're in calculus, we have a definition so we can check. So we know that we are supposed to just take the limit, and if we get infinity on the end of any kind, it's a vertical asymptote. So it's very simple. You calculated the point A, so we're going to go and test x goes to negative 6, x goes to 6, and be done. So let's go and do the limit. X goes to 6. You can do minus or plus, it doesn't matter from either side. X minus 6 over x squared minus 36. And we need to do this limit. If we get infinity, you have asymptote at 6. If you don't get infinity, you don't have asymptote at 6. It's very simple. All right, so can I plug in and solve? No, right? Because we get 0 over 0. So we have to use some other witchcraft. What should we do? Factor, very good. So x minus 6 on top. X minus 6, x plus 6. These cancel. And now I have to worry about limit. X goes to 6, no coughing, minus. From the left, 1 over x plus 6. 1 over 12. Well, that's cool on many fronts. First off, did you realize that 0 divided by 0 is 1 over 12? I know, it's awesome. Welcome to calculus. Yeah, try that in your calculator. See what happens. It's going to explode. So, yeah, 0 divided by 0 is equal to 1 over 12. That's clear in this calculation. Did we get infinity? No, right? We did not get infinity. So do we have asymptote at positive 6? No. Right? Let me write that in blood. No infinity. So no VA at x equals 6. And here's screaming at the end. Right? Calculus theorems and calculus definitions, that's what you are using to solve problems. You have to learn the red statement up here, which says, okay, take the limit. And if the limit is infinity, you got yourself a vertical asymptote at that number. We just ran the limit at 6. Pre-calculus says, oh yeah, you got the asymptote there. Don't worry about it, right? Well, when we run calculation, we actually get that there's no infinity, and the calculus says no asymptote there. Let's check the other value. So limit x approaches negative 6, left or right, doesn't matter, x minus 6 over x squared minus 36. Same calculation steps, right? We'll factor because we get 0 divided by 0. So next time someone tells you divided by 0, what you say? It's 1 over 12. These guys cancel. And now we have limit. X approaches 6, not negative 6, minus of 1 over x plus 6. Okay. What now? Well, luckily you can graph this and solve. Because if you plug in negative 6, you get 1 divided by 0. So 1 divided by 0 is not something that we would calculate limit with. So we just go and say, we'll look at the graph. You sketch the graph quickly. You know that plus 6, so that's going to give you a vertical asymptote at negative 6. And you draw your 1 over x function. As you are approaching from the left, this is going to be equal to negative infinity. And yes, there it is. So, vertical asymptote at x equals negative 6. So this problem turned out to have 1 asymptote. The pre-calculus was promising 2, right? The positive 6 and negative 6. But the calculus says no, only 1. Now, if you are to take your trusty graphing calculator, TI-80 whatever, and you graph this function, you will come up with a graph like this. So they will be clearly at negative 3. And then it would have, not negative 3, negative 6. And at positive 6, it would have this open circle. You would have the open circle. On your calculator, that open circle, if you zoom in, would be a missing pixel. You will literally see like that. There will be a pixel missing at that location. And you can zoom in on that. So if you are to graph this stuff, do you guys have the... I mean, you don't need it. But if you want to, you can just zoom in and come up with that. So we've seen that this point here was 6 and 1/12. That's exactly what the limit calculated, right? And we have the vertical asymptote on the other side, x equals negative 6. Please make sure you are not triggering my allergies. If you write something like this, it's immediately crossed off. the whole thing, because this means nothing. You have horizontal lines that are y equals a number, and you have vertical lines that are x equals a number. This has no meaning in mathematics, so don't write it. Cool? Okay, thank you. No, I have to be very careful because the allergies they're triggering a response in my wrist. It's a circular motion, and it's bad. So don't. Right. So, asymptotes. They're important in the design. Those of you that will become engineers, you stay away from asymptotes, right? They trigger infinities. And infinity manifests in our realm as an explosion. So if you're designing something, you might want to, unless you are designing explosives and things, you want to stay away from explosions. If you're designing, let's say, batteries, hashtag Sony and Samsung and stuff, right? You have to make sure that design is such that all of the mathematical functions used in your designs are vertical asymptote free for the segments that you actually need in your design. Now, here is a very simple application that shows off the asymptotic behavior and what it does in nature. Well, nature being a room. So, the Ohm's law for electricity, right, says that current is voltage divided by the resistance. Current is measured in amps, and generally your cell phone chargers today, the fast chargers are 2.1, 2.5 amps, and so on. Computer chargers, go so 2-3 amps for chargers. The voltage in the outlet is 118, but call it 110 volts. That's the potential, right? That would make the current flow. And then you have resistance, which is what you plugged in, that closes the circuit. So technically, if you have a battery here that is positive, let's say, on that end, and then you put some kind of light bulb, and then there is a switch, and you close the circuit. So once you close the switch, the current will flow, and the light would run. So all of the lights and everything works that way. So it's a very simple thing. And you can literally think of it as water flowing. As soon as you close the circuit, the current, which is just the motion of electrons, it would just go through the whole thing. Now, what is going on now? When you have your current as 110 over the resistance, and you send resistance to 0, where is current going to go? Well, current is going to go to infinity, which is what we just studied in the limit. Now, current is proportional to temperature. So if the current is going to infinity, temperature is trying to go to infinity in infinitely small interval of time. That's why every time you short electricity, it sparks, and it's a mini explosion, right? It's a mini explosion because first, there's nothing to ignite. Second, it's not as violent as explosives, but still, it's an explosion, right? You see the and your circuit breaker pops, and you have to go reset and work all of those things on. So there you go. As you are making this, so now what's happening? Your current just tried to reach infinity, right, at certain point, and that's exactly what we did today. So it's extremely important in the design. You guys are going to, when you take your third and fourth 100 level courses at the 4-year school, these things come back in chapters where you are talking about design and different things. So it should make sense at that point. When you see it today, it's more like, okay, let's talk about this. We have the concept, vertical asymptote definition, example, applied example, and bye.